Good evening, everyone joining on Radio Sophia. At a time when things around seem too tragic, the only hope we have is for a spell of magic. Magic that not only carries art, but is also strongly embedded in science. Magic that not only hijacks our mind, but also exposes its blind spots. So get ready to be mesmerized by academician cum magician, Professor Gustav Kuhn, as he answers a long pending question: what can magic tell us about the brain? Professor Gustav is a reader in psychology at the Goldsmiths, University of London, and also the president of the Science of Magic Association, and a member of the Experimental Psychology Society and the Magic Circle. He has contributed to several diverse research areas, including social cognition, consciousness, attention, illusory experiences, magical thinking, free will, misdirection, and a range of areas related to the scientific study of magic. The breadth of his work is not only seen in scientific contributions, but also in his engagement to bring science to the public and bridging the gap between magic and science. All over to Professor Kuhn as we look forward to a magical session.
Hello and welcome. Hello from London. It's lovely to be here with you. So do you remember the first time you saw a magic trick? Now, this may have been an uncle making a coin appear from behind your ears, or a really silly trick like this. Now, I love magic, and I've spent most of my life dedicated to this weird world of deception and illusions. In the first part of my career, I simply used magic as a way of entertaining people. But I'm now the director of the Magic Lab at Goldsmiths, where we use magic as a way of studying a whole range of psychological principles. So, for example, we use magic to understand misdirection and perception. We use it to understand magical beliefs, so why people believe in real magical phenomena. But we also use it to study free will. And so what I would like to do today is take you on to a little journey through this world of science and magic and explain the psychological nature of magic, and in particular examine the psychological reasons as to why magic works. So let us start off by thinking about what magic is. Now, magic is one of the oldest forms of entertainment, and yet very little is known about the experience that magic elicits, as well as the psychological mechanisms that allow you to experience these experiences. So a few years ago, we carried out a neuroimaging study to try and understand the neural correlates of what magic is. Because even though magic can elicit a whole range of emotions, from surprise, wonder, bafflement, maybe shock, one of the things that's central to magic involves the conflict in beliefs. So I think of magic as a social construct that results in a conflict between the things that you believe to be possible and the things that you've just experienced. So right at the beginning, when I made that coin appear out of nowhere, now I know these Zoom kind of magic tricks that don't work very well, but hopefully some of you will have experienced a little bit of amazement. But most importantly, you will have experienced the conflict between the things that you believe to be possible, namely, you all know that objects can't simply appear out of nowhere, and the things that you've just experienced, yet namely a coin appearing out of nowhere. And so what we did in this study was we used fMRI, which allows us to measure the brain areas that are particularly activated whilst you're thinking about certain things or doing different types of tasks. And we got people to lie in an fMRI scanner whilst they watched a whole range of video clips of different magic tricks. These are all me performing some form of magic tricks. They weren't great tricks, but they were sufficient to elicit at least some form of wonder. Now, the results were really surprising, because what I have here is a slide showing the brain areas that are particularly activated whilst they were watching these types of magic tricks. And two areas became activated. One of them, which is known as the dorsolateral prefrontal cortex, and the other one known as the ACC. The thing that's really surprising about this is that these are brain areas that are generally involved when we experience other type of conflict. So for example, right now, you're all trying to listen to what I'm saying. There may be lots of other things going on in your background, and that creates a cognitive conflict between you wanting to attend to what I'm saying and all of these other external distractions. Now, it turns out that these other forms of conflict activate very similar neural areas. And so this gives us a lot of confidence to suggest that at the foundation of magic is this conflict between the things that we experience and the things that we believe to be possible. But how then can I get magic to work? Now, I'm going to be completely honest with you. I don't have supernatural powers, nor does anyone else I know who performs magic. And instead, what we magicians do is we exploit lots of intriguing psychological tricks to trick your mind into experiencing things that you believe to be possible. And so for the next part of this talk, I would like to take you on a little journey to explore some of these psychological tricks, and hopefully that will give you a bit of a better insight into your own mind. The two tricks that I'm going to be looking at are misdirection. We're going to examine lots of these blind spots in our conscious experience. And in the final part, we're going to look at forcing and the illusion of free will. Let me start by exploring some of these blind spots. As I'm looking around this room here, I feel like I'm aware of everything. And I feel I have a complete representation of the outside world inside my brain. However, a lot of the psychological research illustrates that this experience that we have is an illusion, and it's an illusion that's riddled with blind spots. So let us now examine some of these blind spots, and to do so, we're going to do a little exercise. So what I would like you to do is get a piece of paper, something like this, and then a pen, and draw two circles or dots on the piece of paper so that it looks a little bit like this. And what we're going to do is we're going to make one of these dots disappear. I'm going to remove my blinds because it works a little bit better. Hold the piece of paper in front of you, close one eye, so close your left eye, and keep your eye on the dot on the right, so this one right here. Now, without moving your eyes, move the piece of paper a bit closer or a bit further, and you should at some point get to a point where that other dot completely disappears. So I've got it now. So if I'm looking at the dot on to my left, the dot on the right disappears. If I move my eyes again, it comes back. I'm just going to give you a bit of a brief moment to play around with this. You just need to get the distance and the geometry right for that dot to disappear. So this is known as the blind spot, and the reason why it works is because of a bit of a weird engineering error in the human eye. So what I have here is a diagram of the human eye. We've got the world out here, and the world is projected through the lens onto the back of our eye, which is known as the retina, and the retina is covered in thousands of little photoreceptors that all encode the visual information and then send it back through the optic nerve to our different neural centers. The problem with our eye is that this point here, so at the optic nerve, where all of these nerve bundles have to leave the retina, these nerve bundles displace any photoreceptors. And so what this means is that we've got this blind spot right here upon which we don't actually have any photoreceptors. And so what this means is that any visual information that falls onto this spot isn't encoded, and therefore we are blind. So the reason this blind spot illusion works is that once you get the geometry right and the information is projected onto this spot, you simply won't be able to see it. Now, that's kind of cool, but here comes a truly amazing bit. How many of you have ever seen this blind spot? I haven't. I know it's there, I've demonstrated it, I understand the physiology as to why it happens, and yet I don't experience it. It's as if my mind is just papering over this huge gap in my visual experience. And so the blind spot is a beautiful illustration to demonstrate that you can have these blind spots in your conscious experience, and yet you're completely oblivious to them. But this is only the beginning of the journey. So what I would like to do now is really move this further. And as we go along this journey, we're going to increase the size of these blind spots. So let's have a look at the next one. Have you ever noticed your eyes move? Stand in front of, so next time you stand in front of the mirror, try and look from the left to the right and try and spot your eyes move. You can't. And the reason why you can't see your own eyes move is because our visual system shuts down every time we make one of these saccadic eye movements. And again, from an engineering point of view, this makes a lot of sense because anyone who's tried to take a picture with a wobbly camera will have realized that taking a picture with a wobbly camera ends up with a very blurry image, and that's information that is pretty much useless. And so in the drive for efficiency, our visual system has adopted a strategy to just simply shut down any visual processing whilst you're moving your eyes so as to save cognitive resources. So this makes a lot of sense. And so every time you move your eyes, this process of saccadic suppression shuts down any information processing. But again, like with the blind spots, we are oblivious to this blindness. It's for about 100 milliseconds during each of these eye movements. And again, I can hear you all screaming out through Zoom saying, well, that's not really that much. Well, trust me, it adds up. So if we are blind for about 10 milliseconds per eye movement, that means we make about 3 eye movements per second, which accounts to about 150,000 eye movements per day. During each of these eye movements, we are blind. And so if you do the maths, it turns out that we are blind for about 4 hours per day. So a quarter of your day, you are living in darkness. And yet, like with a blind spot, you are oblivious to this darkness. So far we've looked at 2 blind spots that are directly related to the physiology of the eye. But vision doesn't happen in the eye. Although our eyes capture all of this visual information, most visual perception happens inside our brain. And even deep inside our brain, we can find huge blind spots in terms of our conscious awareness. So let me show another one of these. To do so, we're going to play a little game. It's called Spot the Difference. Some of you may have played this as a kid. I know my kids always do this at home. In Spot the Difference, you get 2 pictures presented next to each other, and there's a slight change between the pictures, and all you need to do is spot the difference. Now, we're going to do this in a slightly different way in that rather than me showing the pictures next to each other, I'm going to cycle through this. I'm going to show you one picture, it's going to disappear, and then the changed picture will reappear. So what I would like to do, we can maybe use the chat function for this, if you've got access to the chat function. And once you spot the difference, just type in yes into the chat. So we're going to do this now. So this is the picture from the Royal Institute. So I'm going to play this now. And so use the chat. So as soon as you spot the difference, type in the chat that you spotted it. Don't say what it is, but tell me that you've actually spotted it. Can't see anything in the chat yet, so I'm going to sort of like let this go a bit. Now this should be okay. So we've got a couple of responses coming in. So this should be really easy. But so for those of you who haven't spotted it, have a look up here. So we've got this picture up here. So this is a phenomenon known as change blindness, and people generally find it very difficult to spot these kind of differences, which is why it's known as a blindness. But once you become aware of it, so once you know what it is, then this difference becomes completely obvious. And so what change blindness illustrates is that even though you feel that you should be able to notice all of these things, we're simply blind to them. We're blind to pretty much most things that we don't attend to. So let me give you kind of like one of my favorite examples of this. Oops. So we're going to do another attention test. So this time I'm going to show you a video clip of 2 teams of basketball players, one wearing white shirts and the other one wearing black shirts. And what I would like you to do is keep a mental count of the number of times that the players pass the ball. And they're going to do two different types of passes. So they're either going to do a direct pass or a bounce pass. So to make the task a little bit more difficult, try and count to keep separate counts for the number of times that the white team performs a bounce pass and a direct pass. Now, I know it's difficult, but try not to give up. So you're ready? And then, so let's go. Okay, you can stop counting now. I'm actually not interested in the number of passes. The real question is, did you spot the gorilla walking across? Now, again, in the chat, give me an indication. So type in yes if you did spot the gorilla, and type in no if you didn't spot the gorilla. So let's see. So I've got a no, yes, yes, no, no. Yes, so a mix of responses. So for those of you who didn't spot it, I'm going to show you the same video clip again. So it is exactly the same clip. So this is a lovely study by Simons and Shibris. And what's happening here is that your attention is being absorbed by the difficult task of counting. And if your attention is absorbed in this task, about 60% of people fail to notice the gorilla walking right across. So what's happening here is we've got this blind spot of this really obvious thing, namely a whole gorilla walking across the screen, and yet you simply don't see it. So what a lot of the research in psychology is telling us is that even though you feel that you are aware of most of the things that are going on around you, this is really an illusion. And it's instead our conscious experience of the world is riddled in blind spots. And these blind spots result from the physiology of the eye, the way we encode information, as well as a lot of these attentional processes that process all of the visual information later on. So how is this related to magic? Well, magicians exploit a lot of these blind spots to create these illusions. And one of the main principles that magicians will use is this principle of misdirection. And so a lot of these perceptual illusions took the scientific community by surprise. Even actually when they were demonstrated at conferences, a lot of scientists were really surprised that people would fail to see these obvious things happening in their environment. And yet magicians have used many of these principles for hundreds of years. So this is a lovely 15th century Dutch painting showing a street magician performing the cups and balls. If I do this talk live, I like to perform this illusion, but it doesn't work very well on Zoom. So I'm afraid you're going to have to just take my word for it. But this is an amazing magic trick in which little balls appear and disappear, and it heavily relies on manipulating the audience's attention. And you can see this poor guy here is completely being sucked into the magician's misdirection. So much so that he also fails to notice that he's being pickpocketed here at the same time. And so a lot of magic relies on exploiting these attentional loopholes. And this is one of the things that we study in the Magic Lab. And so as a scientist, I'm interested in studying these principles because they can tell us a lot about how we perceive the world in the real world. And just to give you a quick example of this, these are the type of stimuli and tricks that we use to study misdirection in the lab. So for this trick, I'm going to show you another very short magic trick. And again, I'd like you to try and work out how it's done. It's not the most amazing trick, and I've filmed this many, many years ago. So just watch the trick. Now, again, you can maybe use the chat and give me an indication as to whether you saw how the light had disappeared. So again, by typing in yes or no, so that we can get a bit of an idea as to how many of you saw it. So let's wait for some of the responses to come in. No, actually, looks like none of you actually saw it. So that's great. So that means that the misdirection worked very well. So let me show you the same clip again. So this is exactly the same clip. And now hopefully there's a big aha kind of reaction, at least when I do this live. Again, can use the chat. Did you see it now? Did anybody see it? Delighted being dropped? Yeah, it was dropped. So just for those who still didn't see it, I'll play the same clip again. So what's happening here is I'm using lots of different attentional cues to misdirect your attention. So I'm picking up the light, I'm making a bright light here, and I'm using this to distract your attention from the place where the lighter is being dropped. So in some way, this is very similar to what I did in the gorilla illusion, but rather than asking you to do a counting task, here I'm using lots of these different misdirection principles to distract your attention and therefore prevent you from seeing things happening right in front of your eyes. So we can use, for example, we can use eye tracking technology to try and work out whether these tricks work and whether this misdirection works. So what I have here is, so eye trackers allow us to measure precisely where people are looking whilst they're interacting with this kind of material. And what you'll see here is these are about 60 participants all watching this magic trick. And we can sort of use this eye tracking data to work out whether the misdirection works. And you can see here, most people are beautifully misdirected. And so we use a lot of these studies on misdirection to try and understand some of these attentional blind spots in the hope to try and develop techniques and interventions that allow people to actually be able to spot things properly in their world. And so what this then tells us then is that a lot of this research on attention and misdirection tells us that we are essentially blind to the things that we don't attend to. And so although that you feel that you can multitask and you can experience all of these things in your environment, unless you attend to something, you simply won't be able to see it. But what's even more surprising is that we are oblivious to this blindness. In other words, we are almost blind to this blindness. Like with the blind spots, even though I'm telling you it's there and you understand that it's there, you simply don't notice it. And this blindness of the blindness is really problematic because it means that we often overestimate our ability to be able to see things. So for example, with multitasking, people are perfectly happy to drive a car whilst talking to someone on a mobile phone. It turns out that is a really dangerous thing to do. In fact, talking to someone on a mobile phone is as dangerous as driving whilst being illegally drunk. The problem is, of course, that the phone is distracting or misdirecting your attention. And in the same way that you don't see the gorilla or you don't see the lighter being dropped, that attentional misdirection can prevent you from seeing the oncoming traffic. But because we are so blind to this blindness, means it's very difficult to change people's behavior. It's a lot easier to tell people, well, don't drink and drive, than it is to tell people not to drive, to stop using a phone whilst driving. But hopefully a lot of this research and misdirection and attention can help us illuminate the public as to the impact that attention and attentional distraction has on your ability to perform tasks. So now that I've told you just about how little you see, let's examine the extent to which you can actually trust the things that you do see. Let's start on visual illusion. What do you see? Again, can you maybe use the chat to tell me what you see in this picture? I'll just wait for some of the responses to come in. A duck, a rabbit, a bird, a duck, rabbit. So this is known as a duck-rabbit illusion, and it's a class of illusion that is generally known as bistable images. So some of you will see this as a duck. So if you see it as a duck, you experience this as the beak, and here you've got the eye. Others will see this as a rabbit. So in which case, these back here are the ears rather than the beak, and this perception can switch from one to the other. You'll never be able to see it as a duck and a rabbit simultaneously, but your perceptual experience of this picture will switch from one to the other. Now, what's really interesting about this illusion is that it illustrates that our perception of the world can change even though the world is stable. So as your perceptual experience is switching from one to the other, nothing is happening to the image. It's still exactly the same image. And the reason for this is that perception is all about interpretation. So our eyes provide us with valuable information about the world, but the way that you perceive the world depends on the way that your brain is interpreting this information. And so if your brain interprets the information as a duck, you experience it as a duck. If you interpret it as a rabbit, you will experience it as a rabbit. So what this means is that we can then start playing around with your perception. So let's kind of play some of these perceptual games by playing around with some visual illusions. This is known as the shepherd's table illusion. We've got two tables here, one on the left and one on the right. And if I'd ask you which of these looks wider, most of you will answer the one on the right. The surprising thing is that they're exactly the same. So these surfaces are identical. And I can demonstrate this by removing some of the context. I'm going to remove the legs and I'm going to rotate these, and you can see that they're exactly the same. It's exactly the same surface, and yet you perceive them as being different. And again, if I add the context, we experience them as different. And so what's happening here is your visual system is making a guess as to what's the most likely shape of these tables, and it's this interpretation that determines the way that you perceive the tables. This is with shape. The same can happen with color as well. This is known as the dress illusion, and it's an illusion that almost broke the internet. So again, we can maybe use the chat to see how you see this. How do you experience these lines here? Do you see them as being black or gold? So I personally see it as black. I'd be interested to see how you see what you see. Black. So far we've only got black in there. Oh, black and gold. So this is an illusion whereby people experience this color as being very different. And the reason why this illusion works is because your perception of color again relates to the way that your brain interprets this color. Just to give you an illusion where we can bring everybody together, so people see this as being very different, let's play with an illusion where everybody is hopefully going to get a very similar experience, again with color. So this is a beautiful illusion that was created by Bo Lotto at UCL. And if I've got a look at this this square down here, this looks orange, and then I've got another brown one up here. So hopefully you'll all agree that perceptually, these two squares look completely different. What's really surprising is that they're exactly the same. And again, I can demonstrate this by removing some of the context. I'm going to remove the context. I'm not changing the color, but as soon as I remove all of this, you can see that they are exactly the same. When I add the context, your perceptual system interprets them as being different. So what's happening here is that your visual system is making a guess as to what's the most likely color of these squares given this information. And because this one on the top is surrounded by brightly illuminated squares, we assume that you are seeing this on a really bright day, whilst this one down here is surrounded by darker squares. So you're assuming that this is what it will be like on a shady day. And this information about shadows and the overall lighting overrides this sort of like this bottom-up sensory information. And so what this tells us then is that the brain, our perception of the brain isn't necessarily only related to what's out there, but it's much more related to the way that you're interpreting this information. And again, this is a principle that magicians will often exploit. So a lot of magic tricks rely on this. So for example, here, this silly little trick that I showed you right at the beginning, Well, the way it's done, I'm just kind of like moving my fingers like this. But again, kind of like your brain is making an estimate as if it's kind of like the most likely situation is that this is a continuous finger. And if I then start to remove it away, it creates this visual illusion. And so a lot of these illusions are at the heart of magic. But I've left the most amazing illusion to the end. So this here is known as the vanishing ball illusion. And again, I'm just going to show you the video clip. So just watch the illusion, and then I'll ask you a few questions afterwards. Now, again, maybe you can use the chat. Can you tell me how many of you saw on the final throw, how many of you saw the ball move up and leave the top of the screen? So again, use the chat function to see whether you can answer that question. So maybe with a yes or a no. So if you saw it move, if you saw the ball leave the top of the screen, no, yes, no, 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 yes. So again, we get sort of like different responses. Now again, when we do this in a lab, about 60% of people see a ball leave the top of the, move up and leave the top of the screen. I'm going to show you the same illusion again. So I'm just going to play exactly the same thing again. So watch it again. 2. And on the third trial, I simply pretended to throw the ball up into the air. So this is known as the vanishing ball illusion. And the thing that's really intriguing here is that people seem to experience something that they expect will happen, but hasn't actually taken place. Now, the trick is quite cool, but the explanation for this trick is even cooler. So let me give you an explanation by highlighting one of the biggest challenges that the visual system faces. Let's look at how vision works. So in order for me to be able to see something, my eyes have to capture visual information. And we saw in the first part how this information is encoded on the retina and then sent through different neural centers to the visual cortex and other areas in the brain. And it's these brain areas that are responsible for our perception. But here comes the problem. Information transfer is not instantaneous. It takes about 100 milliseconds or more for the visual information to travel from my eye to the visual cortex. So what this means is that by the time my brain has received the information about an event in the world, the event has already happened. This is a bit like with a thunderstorm. So in a thunderstorm, you've got thunder and lightning happening at the same time. And yet, because sound travels significantly slower than light, we experience the thunder. So we hear the thunder after we see the lightning. And that's the same with perception as well, because it takes time for the information to travel to the brain. Events have already happened, so we should be experiencing the world in the past. Now, just to put this in the context, I know 100 milliseconds doesn't sound like that much, but if you're walking at a normal speed, so imagine that you're walking at about 1 meter per second, a tenth of a second neural delay would mean that you should be seeing the world as lagging about 10 centimeters in the past. And yet, of course, that's not what happens. I feel like I am seeing the present rather than the past. So how does the brain solve this conundrum? Well, the way we do this is by seeing the future. So our visual brain uses incredibly clever tricks to use information from the past to try and predict the present. And so what you are seeing as the present is not the present, but it's your brain predicting the present based on information from the past. So you are literally all seeing the future. And that, for me, is one of the most amazing feats of the human brain. And so the reason why the vanishing ball illusion works is because this is an example of you experiencing something that is not happening, but your brain is expecting it to happen. So what we are seeing is based on our expectations. And it's a little bit like with a dog. So if you've ever played around with a dog and you throw a stick, like you throw the stick a couple of times and the dog will start running for it. If you then just pretend to throw the stick, the dog will simply run. The visual system is exactly the same. So if you're tricking your brain into anticipating something that will happen in the future, you will see this even if this hasn't happened. And so what a lot of this work on illusions is telling us is that seeing truly is believing. We see the world not necessarily because this is the way the world is, but we see the world because this is how we believe the world to be. So I was going to talk to you a little bit about forcing at the end, but I think I'm going to kind of like bring it to an end here because I don't want to overload you with loads of information. And it'd be great to have a bit of a chat about this. But anyone who's interested in learning more about the science of magic, I've recently published a book called Experiencing the Impossible in MIT Press. And it's a book written for the general public, and it explores lots of these areas as well. It also involves kind of like about hypnosis and mind control techniques and other fascinating perceptual and psychological illusions. So I hope this has given you some insights into how magic can be used to understand some of these blind spots and some of the psychological tricks that our brain is playing on us. And so I'll leave it now open to you to kind of like ask questions, and hopefully we can have a little bit of a discussion about this. So I will stop sharing my screen now.
Yeah, thank you, Dr. Gustav, for this really mystical presentation. We request people to have their questions. I mean, before people start asking questions, Dr. Gustav, I'll have one question for you. So so this is something that I had tried once. So there was a magic show that had happened close to my house. And I realized that, I mean, after the first instance, I thought of going to the magic show for 2 more times. And yet I was unable to spot any of the, the misdirections or any of the inefficiencies that were coming out. But why do you feel even after such repeated, interactions or repeated visibility of such events, people cannot kind of figure out what's wrong?
Yeah, well, the tricks that we use here are very simple tricks because we use them to study how the brain works. We're not interested in creating amazing illusions. And in fact, if we'd have tricks that would be too good, we just simply, they'd be useless to study psychologically, because if everybody's deceived by them, well, we don't know what the differences are between those people who are tricked by it and those who are not. So this is why the type of tricks that we use in the lab are generally quite weak. If in the context of a magic performance, magicians will use lots of different layers of deceptions, and those deceptions, hopefully, if the magician is really good, will prevent you from being able to work out how the trick is done, even if you watch it several times. And I mean, it's interesting when I remember when video recorders were invented, some magicians were really worried. They thought, well, now that people can record a magic show and play it back, that'll be the end of magic. Well, it clearly isn't. I mean, even with YouTube, you can re-watch magic tricks several times, and magicians have developed deceptive techniques that will prevent you from actually working out how the tricks are done, even if you're watching them several times. I mean, watching something for the second time, it does increase the chances of you being able to work out how the trick is done, because you know what's going to happen, and a lot of magic relies on surprise. You might be able to allocate your attention more strategically as well, so that should give you a better chance. But if you've got a really good magician, you hopefully wouldn't be able to spot the secret, even if the same trick is repeated.
I think Professor Biju Paul Abraham has a question. Professor?
Yeah, so thank you, Dr. Kuhn. That was an excellent presentation. The blind spot issue I had realized earlier from some other exercise that I did, but the others were completely new to me, and I really didn't know that you could spend 4 hours a day without actually seeing something. I had two questions. The first is obviously from your session, it is clear that we don't see a lot of what is happening around us. So in terms of how we could change our behavior or the way in which we observe things, is there some way by which we can sort of be aware of this and try to overcome the problems of this? So I'm looking at it more from a personal safety kind of perspective. When you're driving or when you're going outside, perhaps when you're with children and you're distracted, is there something that we could do differently that would enable us to overcome some of the problems that this creates? The second question was, would you like to take that first and then should I
Let me take that one first. That's a really interesting point. So, even though I point out all of these blind spots, it's sometimes people come away from this thinking, oh, this means that the visual system is really poor. It's not. What this illustrates is just that we are incredibly efficient. So if you think about the brain from an engineering perspective, processing information requires resources. And so there's a trade-off. Either you have built a system that processes all of the information, and what that means is that we would have to dedicate vast amounts of neural processing to processing all of this information. And of course, all of this neural processing has to be supported by a brain. We've pretty much packed our brains are very dense. Like, you can't pack any more neurons into our head. So we'd have to have these huge heads. That's sort of like the trade-off. And so instead, evolution has pushed us down this route of efficiency. So all of these blind spots, particularly these attentional blind spots, they are very clever tricks that the perceptual system is using to ensure that we get the information that we need at any particular point in time. Now, improving that is quite difficult. There's lots of techniques that have been tried, from drugs to brain training, to trying to find ways in which we can increase our ability to process information. And very few of these techniques tend to work. I think the best intervention is changing your overall behavior. So becoming aware of these blind spots so that you can actually change them. Because the big danger is that, especially now as our attentional resources are being pushed to their limits, like we are using loads of different devices at the same time. You might be driving, checking your phone, and you feel like you should be able to do these tasks simultaneously. And yet this is really where the biggest blind spot is. So the biggest way in which, the best thing that you can do is to have some awareness of these blind spots, and then to make sure that you change your behavior accordingly. So when you're driving, you make sure that you're not being distracted. When you're doing your work on the computer, now you might think that you can multitask and have loads of windows open. That's an illusion. We simply can't. We don't have the capacity to do so, because that's not what our brains have evolved to do. And so take action. So try to shut down everything else and just focus on that one task. So I think these behavioral modifications are a much more effective strategy than trying to find some way of actually boosting our brain capacity. Our brains are amazing. There's very little scope for improvement there. Our behavior are sometimes sort of like suboptimal.
Thank you. My second question was related to something that you said at the very end about mind control. I'll certainly, read your book. But what I was thinking was, when you look at it, from, because of my own interests, I'm looking at it more from a political perspective. So when you look at, let us say, how politicians, for example, or other leaders might, sort of exploit some of this for increasing support. So I'm thinking of things like, let's say, Brexit or Trump and so on. And because so much of politics these days is visual. I mean, you hardly see a politician face to face, but you see them on television and see them in debates and so on. So do you think, some of this could be at play as far as, populism and populist leaders are concerned, apart from the messaging? Is there some of these blind spots that are being exploited?
Yeah, definitely. I mean, so in my talk, I've only talked about a very small part of our research on magic. So I've only talked about the visual part, but misdirection involves other processes as well. So the principles that I've talked at here are all perceptual misdirection, but we can also misdirect your memories as well. So these illusions that I've illustrated here, many of them also happen with memory. So memory does not work like a video camera that records information so that it can be played back in its original format. Memory is a reconstructive process, and again, that means that you can start manipulating this. So there's lots of work about, for example, by Elizabeth Loftus, showing eyewitness testimonies where leading questions and other misinformation can influence the way that you are remembering something. And of course, this is something that happens in politics often. So this is a form of misdirection that is frequently used in the Brexit debates. I don't know how, this is kind of like a very UK, or with Trump as well. Promises are made and then these promises are changed and the whole narrative changes, and sort of like the way that all of these events are reconstructed. We also distinguish between another form is reasoning misdirection. So this is manipulating some of these reasoning processes as well. And so, yeah, there's lots of parallels between misdirection and politics. And many of these principles are used. So, for example, there's, the kind of Boris Johnson used this. This kind of Crosby called this the dead cat maneuver. He describes that if you got a meeting and you throw a dead cat on the table, everybody will be talking about the dead cat, nothing else. That's a metaphor, but Trump will just blast out all of these tweets, and these tweets will capture the world's media attention, and that can distract or misdirect from everything else as well. And so we are now actually we've got a big project looking at the way that misdirection is used in public health as well, and the relationship between misdirection and some of these larger sociological and political questions. So yes, there's lots of different ways. Again, I sort of discuss a lot of this more in my book as well.
Thank you very much. So it's a fascinating talk. Thank you.
Thank you, Professor Abraham. If anyone else has any other question, you can post it. Professor Kuhn. I don't see any other questions coming right now. I think we can call the session a close. It's been a fascinating session. I mean, we've got to know a lot of things, and maybe once we start reading your book, we will get a hang of more mysteries around magic and deception. Thank you, Professor Kuhn, to be part of this session, and we look forward to maybe meeting you sometime in India whenever you come here.
Hopefully that'll be possible at some point soon.
Sure. Yes. There's someone who's asking for the name of the book. Shantanu is asking.
Oh, it's called Experiencing the Impossible.
Experiencing the Impossible. Yes, Experiencing the Impossible. Yeah. So thank you, Professor Kuhn. And
thank you for having me. Stay safe, and who knows, hopefully we might be able to see each other in real life as well at some point.
Thank you. Thank you very much.
Great. Bye. Goodbye or good evening.
Bye.